Hello all, my name is Ashutosh Rastogi. I'm a teacher by profession. My mission is to impart quality education for all. For that purpose, I'm creating these videos. If you appreciate my work, then please do like my video and subscribe my channel so that I could get the motivation to prepare more videos. Anyways, today in this particular lecture, we're going to discuss about the classification as well as the comparative analysis of your AM systems. So these are the outlines. We're going to start up with the introduction. Then we're going to discuss about the classification of AM systems, obviously on the basis of their generation mechanism. Then we're going to discuss about the spectrum of your double sideband suppressed carrier systems as well as your single sideband suppressed carrier systems and your vestigial sideband suppressed carrier systems. Then we're going to discuss the comparative analysis of your AM systems such as your full AM, or you could say your double sideband full carrier system, double sideband suppressed carrier systems, single sideband suppressed carrier systems, and vestigial sideband suppressed carrier systems. So in our earlier lecture, we have discussed the basics of AM systems such as your modulation, what is it, frequency translation, bandwidth, and power requirement of AM waves. We have also discussed about the generation as well as detection mechanism of various AM systems. Now in this concluding part of our amplitude modulated systems, we will try to give the classification of amplitude modulation family based on their generation mechanism and comparative analysis as per their characteristics or different characteristics that would have been possessed in your different AM system family. So how we're going to classify our amplitude modulation? Obviously, in terms of their generation mechanism, if we are using non-linear devices for the generation of AM system, or we are using certain linear devices for generating our AM system modulation or AM modulation. So for non-linear amplitude modulation, where we'll be using some diode device or any non-linear device to generate your AM system, we can classify our non-linear AM as your amplitude modulation double sideband full carrier system, where we'll be having both the sidebands along with your carrier. So this is your traditional AM waveform. So your linear AM would have been divided into three parts. Number one is your amplitude modulated double sideband suppressed carrier systems. Here in this particular case, we will going to suppress the carrier power. Then another variant is your single sideband suppressed carrier systems, where we will going to suppressing the carrier along with one of the sideband. And third one is your vestigial sideband systems, where we will going to suppress the carrier power. And in this particular case, we will going to transmitting one complete sideband and some portion of the another sideband, so we can rectify or reduce out the losses. So this particular figure is showing the spectrum of your AM systems. So initially this particular waveform is basically showing the spectrum of your baseband message signal. So on this x-axis we will be having this frequency, and on y-axis we will be having this x of f, which is nothing but the Fourier transform of our signal. So this particular signal is basically showing the frequency domain version of your message signal. Now this particular second figure is basically showing the double sideband suppressed carrier systems frequency domain version. Here the bandwidth requirement is nothing but your maximum frequency component minus minimum frequency component, that is Fc plus Fm minus times of Fc minus Fm. So here the bandwidth requirement of your double sideband systems will be equal to your twice of Fm, and this is basically showing the negative frequency counterpart of this double sideband suppressed carrier systems. Then we'll be having this single sideband suppressed carrier systems, where we are intentionally transmitting only a single sideband. We are suppressing the carrier power and one complete sideband, in contrast with your double sideband suppressed carrier systems. Whereas in your VSB systems, we will be having this one complete sideband and some portion of another sideband. So here in this particular case, the bandwidth requirement will be equal to Fc plus Fm minus times of Fc plus Fv. So here the bandwidth requirement will be little bit greater than your single sideband suppressed carrier systems. So where this Fv is basically representing the vestige or portion of the other sideband. So this particular figure is basically showing the overall bandwidth requirement in your vestigial sideband suppressed carrier systems. So now we're going to give the comparison of various amplitude modulation families. So first we'll start up with your full amplitude modulation, or you could say as your double sideband full carrier system. So this is your traditional AM modulated waveform. So here in this particular case, sidebands are transmitting in full with the carrier. So here all three components are present, that is your upper sideband, lower sideband, as well as the carrier. So if we talk about the generation as well as detection mechanism, so they are quite simpler to generate. That is, with the help of simple non-linear device such as your diode or transistor, we are in a state to modulate your amplitude modulated signal or to generate AM signal. And in the similar fashion, in order to demodulate, simple envelope detector could serve the purpose, which is containing nothing but your diode as well as a capacitor. So obviously its efficiency is very lower, since most of the power would have been contained in your carrier and very less power would have been contained in your sidebands. So obviously the power efficiency is quite lower when we are talking about your traditional AM signals. So here the bandwidth requirement is also high, just because we are transmitting both the sideband for information exchange purposes. So here the bandwidth is twice of the bandwidth of the information signal, which is equivalent to twice of FM. Whereas in general case, we will be only requiring FM bandwidth of your low pass message signal. So it would have been used in your commercial AM radio broadcasting scenario. So this is the basic application area of your AM radio broadcasting system. So one transmitter and many receiver type of scenario would be there in broadcasting scenario. So what is peculiar about your double sideband suppressed carrier systems? So as the name suggests, here we will going to suppress the carrier and we will going to pass in both the sideband, that is your upper sideband as well as your lower sideband. So less transmitted power than the full AM and all the transmitted power is useful, since we are completely suppressing the carrier wave, which is containing most of the power of your AM modulated waveform. So if we are suppressing that carrier power, then obviously less power we need to transmit in order to complete information exchange. So bandwidth requirement is same as we are transmitting both the sideband, and that will be equal to twice of FM. So it requires a coherent carrier at the receiver. Obviously, if you are talking about this coherent carrier, it means that at receiving side we must have to have the carrier information so that we can easily demodulate our signal without having any distortion. So this result basically increase the complexity in the detector, since we will be requiring an external circuitry or some mean by which we are in a state to get the carrier information at the receiving side also, so that at the receiving side your local oscillator can generate the same frequency component that would have been generated at the transmitting side. So it is suited for point-to-point communication. So this is the basic application area of your double sideband suppressed carrier systems, which involves one transmitter and one receiver, which would justify the use of increased receiver complexity. So now next part is your single sideband suppressed carrier system. So here in this particular case, we are only transmitting single sideband, that is either upper sideband or lower sideband, and we are suppressing one complete sideband along with the carrier. So obviously the bandwidth requirement is quite lower in the whole complete AM family. So it is having your good bandwidth utilization, and message signal bandwidth will be equal to modulated signal bandwidth. So in this particular case, both of the bandwidth requirement will remain same. So it is also having your good power efficiency, since all the transmitted signal would have been translated to your actual message or information. So demodulation is harder as compared to full AM. Exact filter design and coherent demodulation are required, since we had already studied about your SSB system. So where we have seen that we will be requiring some high quality factor filters, which is having certain high roll-off factor, which can selectively select one sideband and completely reject the other sideband. So the demodulation part is quite complex. So it would have been preferred in long distance transmission of the voice signal. So this is the basic application area of your SSB-SC signal. Now last portion is your vestigial sideband suppressed carrier system. So here in this vestigial sideband suppressed carrier systems, we will be transmitting one complete sideband and some portion of the other sideband. That is, we will going to transmit lower sideband completely and some portion of your upper sideband, or vice versa. That is, one complete sideband of your upper sideband and some portion of your lower sideband. So vestigial sideband is standard for TV transmission and similar signals. So here, with the use of this vestigial sideband suppressed carrier systems, we are in a state to save bandwidth, or you could say we can save substantial amount of bandwidth. So bandwidth saving can be significant if modulating signals are of large bandwidth, just as the case of your TV, where the bandwidth requirement is in your megahertz, and wideband data signals. So for example, with TV, the bandwidth of the modulating signal can be extended up to 5.5 megahertz with the full AM, and the bandwidth required is your 11 megahertz. So here, if in this particular case we are suppressing the sideband, then we can substantially save the bandwidth of around 3 or 4 megahertz. So hopefully you have get the complete idea about the comparative analysis of your AM family. Just in case of any doubt, you can ask me in the comment section. I'll try to solve them out as soon as possible. These are the references used for preparing these slides. Thank you very much for your patient hearing.